Okay, in this section we're going to be looking at the empirical rule and how this applies to the normal distribution. Now we'll be working with this concept across the semester, so you need to make sure that you're clear about how the empirical rule works and its expectations. So the empirical rule is used to calculate the values for the z distributions and the t distributions that we'll be using later on in the semester. So when you look at your charts in the back and they have a z distribution and the t distributions, those are calculated applying the empirical rule. So you don't have to do those calculations, but you do need to understand what they represent and how we use them. So when we're looking at this, here's the empirical rule boundaries set out below in these 3 bullet points, and then they're represented in the image at the bottom. So here we can see 68% of all the data values should fall within 1 standard deviation of the mean, 95% should fall within 2 standard deviations of the mean, and 99.7% should fall within 3 standard deviations of the mean. Notice we're never guaranteed 100%. The most accurate we can get with this is 99.7%. So let's take a look at this in more detail. To do this, we're going to work through the class pulse rate data and look at how this applies to the empirical rule. So here's the questions we're going to ask. What percentage of our students' pulse rate should be within the 1 standard deviation, 2 standard deviations, and 3 standard deviations of the mean? So here we see that represented in the second column, and then we need to look at how this matches up with our own data. Now to work through this, we need to calculate first what are the boundaries for 1 standard deviation, 2 standard deviations, and 3 standard deviations for our particular data set. So here we see the calculations that we go through for calculating 1 standard deviation. We're going to take the x bar, mean, and we're going to subtract 1 times the standard deviation to get the lower edge of 1 standard deviation boundaries, and we're going to take the x bar mean and add 1 times 1 standard deviation to get the upper boundaries. So go through and do these calculations, and then when you finished it, let's move on to the next slide and we'll check them together. Right, you should have gotten 63.4 for your lower of the 1 standard deviation and 73 for the upper level of the 1 standard deviation. Now we need to go through and do the same thing here for the 2 standard deviations and the 3 standard deviations. You're going to use the exact same formula here. The only difference is going to be that you're going to be using 2 times the standard deviation. So for your 2 standard deviation levels, you're going to take the mean and you're going to subtract from it 2 times the standard deviation. To get the upper level, you're going to take the mean and you're going to add 2 times the standard deviation. So pause the video, go through and make those calculations for your 2 standard deviation and your 3 standard deviation, and then we'll move on and check them together. Okay, so for your 2 standard deviations, you should have gotten 58.6 to 77.8, and your 3 standard deviations would be 53.8 to 82.6. So let's take a moment and look at these and visualize them, putting them onto the empirical rule. So here we see our diagram of the empirical rule, and I've marked on here our actual boundaries for these standard deviations. Again, if you are somebody who's very visual, I suggest that you print out a copy of this empirical rule distribution and literally mark onto it your different standard deviation points to make sure that you're getting them in the correct location. So here we can see with 1 standard deviation is going to be 63.4 to 73, and we have 68% of our data values should fall within that range. The second one for 2 standard deviations is 58.6 to 77.8, and we can see that 95% of our values should fall within that range. And the third standard deviation is 53.8 to 82.6, and we should see that 99.7% of our data values should fall within that range. So let's go back and apply this to our chart and see what we get. All right, so our frequency pulse rates, we have 13 of our class pulse rates fall within 1 standard deviation of the mean. All 20 of them are within 2 standard deviations, and thus obviously also all 20 within 3 standard deviations. So taking 13 times dividing it by 20 and timesing by 100, we get that 65% of the class pulse rates fall within 1 standard deviation. So that's a little bit lower than we would expect with a normal distribution, but we can see that 100% of them are falling within 2 standard deviations. So the empirical rule comes pretty close to predicting our data, but not exactly. Now, the next thing we want to ask is, are there any of the class pulse rates that are unusual? So remember, looking from what we talked about previously with the rule of thumb, Any unusual data value is a value that's outside 2 standard deviations from the mean. So, looking at our chart that we produced here, do we have any data points that are outside 2 standard deviations of the mean? No, we do not. Both the lowest value of 60 and the highest value of 76 fall within 2 standard deviations of the mean. So for the class pulse rate data that we've been working with, we do not have any unusual values. All right, now let's apply this to a practice problem similar to what you're going to have on your homeworks and your exams. So here we have a question regarding the freshman weight gain of 15 pounds or 6.8 kilograms. So we have 2 questions we want to answer here. Is the weight gain of 6.8 kilograms unusual? Why or why not? And we also want to ask the question, does this support the legend that freshmen gain 15 pounds? So we've got 2 different questions here that we're going to work our way through. So again, how to get started with this? The first step is to go through and identify the pieces of information you require. So take a moment and look at this and think, what piece of information do you need to know to solve this problem? Well, you're going to need to know your mean and your standard deviation because we have to have those in order to be able to make predictions about what the 2 standard deviation boundary is going to be. So we need that to decide if something is unusual or not. So if the question here is asking you to say, is something unusual, that tells you that you need to be applying the rule, the empirical rule of 2 standard deviations. In order to calculate your 2 standard deviation distance, you then of course need to have your standard deviation, and you're also going to have your mean. So to work through this, we're going to look at using statcrunch. This helps us use larger sets of data. So let's take a moment at opening up statcrunch and getting in and working with it. So the first thing you're going to do is once you get to your Pearson site, you're going to click on, instead of clicking on your homeworks where you've got up there at the top, you're going to click on statcrunch. That's going to be the first part. That's going to take you to a page that then shows you the second image here at the top. Now, if we're entering data manually, which we're doing this time, you're going to open the statcrunch website, okay? If you're going to use data from a class text, which we'll look at later on, you're going to actually open that data set straight into statcrunch. So that saves you a little bit of time of having to type in really large data sets, all right? So then, either way, you're going to get taken to something like this, so you're going to need to click Open statcrunch. I know this means that you're opening statcrunch technically 3 times to get to the program, and I am sorry that is annoying, but that is simply the way the system is set up. So, all right, now we're in statcrunch. Let's go through and look at how we can use statcrunch to help us answer our question regarding the freshman weight gain. So, first step, remember to enter the name of the variable at the top of your columns. This seems tedious, but it's important to be able to come back and interpret your data correctly again. If you just leave them as the variable 1, variable 2, variable 3, that's quick for entering your data and you're getting your calculations, but it may confuse you when you get to the end and you're trying to make your assessments. Next, you need to go through and enter all of your data values all the way down under the weight gain column. All right, next, you're going to click on the button that says Stats. All right, once you click on Stats, that's going to open up a drop-down set of options, and you're going to pick Summary Stats, and then from that, you're going to select the option of Column. All right, once you have those, you get a dialog box that looks like this. Now, you're going to click on the variable name here, weight gain, sorry about the pulse rate incorrection there, weight gain to select it, and it will appear in the box on the right-hand side. Once you have that, you're going to click Compute. And this is going to give you your data right here. So here is, when we're looking at this, here's our various data. Let's go through and identify all the information we get here with our summary statistics. So there's our mean. Now notice you're going to have to apply the appropriate rounding rule to this. Okay? Notice here's my standard deviation now that I need to know. So now I've got my mean and my standard deviation. So I'm actually pretty much ready to go and do my calculations for unusual values. But let's take a look at a couple of other things here first before we move on to that. Notice it also gives me my variance. Okay, so this is going to be different than my strict standard deviation. So there's my variance. Notice it gives me my minimum and maximum values. Okay, so we were looking at our possible values. Remember, we were talking about our range, right? There's the minimum and there's the maximum. And we also see here our quartiles of quartile Q1 and Q3. So we're going to be looking at those again in section 3.4. So we'll come back to that in the next section. All right, so now we've got our means, we got our standard deviations. Now we just have to go through and calculate our boundaries. And in fact, in this case, we just need to calculate the boundary for 2 standard deviations to answer this question. So here we go. We have our 2 standard deviations. So we're going to be taking our mean of 1.2, and then we're taking it and we're subtracting 2 times 4.1. And that gives us our lower range. And then we're going to add 2 times 4.1 to get our upper range. Notice this is exactly what you were doing before in the previous one when we were looking at applying the rule of thumb for unusual values. So now we need to look at this. Does this support, is a weight gain of 6.8 kilograms unusual? In other words, does it fall outside the boundaries of 2 standard deviations for this data set? So take a moment, look at your data, and make your decision, explain why. And again, make sure you're just specifying how it relates to falling inside or outside the 2 standard deviation boundaries. Okay? Next up, we want to also ask the next question, does this support the legend of the freshman 15? Okay? So let's think about that for a moment. If we were looking at the freshman 15, pay attention to how that would relate to the 1 standard deviation that we have identified above. So that's the second part we need, is our 1 standard deviation to answer the question regarding supporting the legend of freshman 15. So when we're looking at this, we can see that A, the weight gain of 6.8 kilograms is not unusual. It falls within 2 standard deviations of the distribution. However, this does not support the idea of most people gaining 15 pounds. Because applying the empirical rule, we can see that 65%, or over half of the population, falls between the range of losing 2.4 kilograms or gaining 5.8 kilograms. So, although 6.8 kilogram gain is not unusual, it is not the norm. All right, so pay attention. This is how we use this information to make specific statements like this of something being unusual. And notice that something it can be not unusual, but it may still not be representative of the norm. All right, so this concludes our section looking at applying the empirical rule. Next up, we're going to be going through and looking at the effects of outliers and using Chebyshev's theorem.